Hi friends, I'm Shravana and welcome back to Sparkling Future. Before starting with today's topic, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, let's start with the first data structure, linked list. We have seen Python list, right? If anyone is not aware of Python list and how to do the operations, please go through the Python playlist. I'll give in the I button. So before understanding the linked list, right, let's see the differences between linked list and a Python list. So Python list, right, this is like a normal list of values. So it is implemented as a dynamic array where elements are stored in contiguous memory locations. Means continuously memory will be allocated for each of the element and indexes will be given for each element. Okay, and linked list is like kind of series of nodes, okay, where each node contains both the data and the pointer. I'll show you the diagram so that you will understand better. For now, just go through this, let's go through this theory first. Okay, so from one node to another node there will be a pointer connection. That's why we are saying this as series of nodes. And list is allocated like a contiguous memory allocation will be there, means continuous memory will be allocated for this each and every element. Whereas for the linked list, because already pointers are there, it can be there wherever the place is available, like memory is available there, it will be stored. The values will be stored in the linked list. Next is Python list will have this random access. Okay, random access to the elements using indexing, and also it supports the operations like appending, insert and deleting the elements efficiently. And similarly, this linked list, right, it should, I mean it won't support random access to the elements, and it has to do the traversal from the head to reach to the specific element. Okay, these are the main differences between list and linked list. Now let's see how these look like and how we can learn this linked list. Now if you see, this is kind of list will be stored in the memory. Okay, this is the list, each element, and it has the indexes. And this is the linked list. This right side is the linked list where each node will have this pointer, means this is the first node, this is the second node, this is the third node, and this is the last node. How we will identify the first and last nodes, sir? First nodes means here head pointer will be pointing to the first node, and to the last node tail pointer will be pointing to the last node. Using this head and tail only, we will identify what is the first node and what is the last node. And if you see, every pointer is pointing to the next node, correct? So similarly the last node, the end of the linked list, will be pointing to the value none. That's how we will identify the tail node. Okay, when we are traversing through the list and need to identify the tail node, then tail and the next pointer we will set it as none, so that it is the end of the linked list. So this is the pictorial way, this is the difference between list and linked list. Okay, and we have seen, right, in the list will be stored as contiguous memory in the memory, right? Let's say this bigger rectangle as the memory, then if you see, in the same manner it will be stored in the memory also, continuous locations the list will be stored. But whereas the linked list will have the pointers, right? So wherever the place is available, it will store the elements like this, okay, in the memory. And how we can identify which one is the next element? Using these pointers. Okay, this is how it will be stored in the memory. Now let's append a new node at the end of this linked list. Let's say this is 50, the element is 50, and we wanted to append at the end of the linked list, means this place. Okay, this next place, correct? So for adding it here, what we have to do, we need to have the last node, this new node, right, I mean this to be pointed by the tail. Okay, tail should be pointed to this one, and then it should point to the none, and this whatever is there here will be removed, correct, and it should point to this one. That is how we can add the new node at the end of the linked list, correct. So for this, what we have to do, we just have to find that which one is at the end, which is having tail, which is having this tail, and which is pointing to the none, and then we just have to adjust the pointers. Okay, so because of this, if you see the order of this, I mean if you want to add it, what we have to do is we have to change the tail and we have to assign none pointer to this one, right, to the next pointer will be none, right. Only those two operations we have to do, right. That's why the time complexity of this is order of n. Okay, why? Because it doesn't matter how many elements are there in the list, we just have to find the end and using this tail, and then we can directly append the node. So how many nodes are present in the linked list, we are not even bothered, and the number of operations to append at the same is at the end is same, right. So because of this, the time complexity of this is order of 1. Now let's try to remove this newly added value. Okay, I'll just remove this. Now if you want to remove this newly added 50, what we have to do, we just have to point the tail to this one, correct, tail to the previous one, correct. I mean in the previous I mean this tail should be pointing to this, I already told you in the previous example. Now what we have to do, if we wanted to remove this, again this needs to be removed, this particular needs to be removed, and all these pointers to be removed, and again this 40 should point to none. This is how we have to do, and tail should point to 40, correct. Okay, but the only thing that points to the 40 node is this one, correct. 30, after 30 we have the pointer to 40 node. So in order to get to this node, because we have to see to the right side, we are very clear what we have to do, we have to assign the tail pointer to 40, and then this node dot next will be none, and then it will be, we have to we will return this 50, it will be done, that till there it is fine. But now here there is a connection, right, from here to here, this connection need to be set it up. So in order to get to this node, okay, we start from the head, from here we have to start, and then we have to iterate through each and every element and find this particular pointer to see that when we eliminate the last one, which is the next node from the back, from this side, which is the previous node, which is the previous node 40, and 40 is pointing to, I mean 30 is pointing to 40. So this one we have to find out, and then we can assign the tail to that particular 40 node. So for this we have to iterate from head to each and every element to find this particular connection to change the tail and none to those one, right. Because of the number of searches here, it comes here and searches for the whether this pointer is this one, for each pointer it will search, right. So it has to iterate through every element in the list to reach that particular previous node position, right. So because of this reason, the time complexity for this is order of n. So always remember, if to perform particular operation, how many iterations you have to do. If that is just one, right, then the time complexity is order of 1. If there are some iterations to go through, means in each iteration if it has to search through each and every element uh, to to find out or to conclude certain position, right, then because of that iterations, the number of operations will be more. That's why the time complexity of that particular operation will be order of n. Okay, next let's try to add at the end. Now we are adding at the end, right. Now let's try to add an element at the starting of this list. So let's take the same element and try to add it here. So here what we have to do, we need this head is there, no, here head pointer to point to this node. That is the first step, correct? This head to be pointing to this newly created node, and then we and then we have to just point the next node to current head. That's it, right? Head to be pointed to this new node, and this next to be pointed to this already currently the first node. So it doesn't matter for us how many nodes are there in the list, correct? We are just adding at the starting, and we are assigning the head to this and then next to this first position. So here, because there is only one operation present, just assigning the head and this one, right? So that's why here the order of the time complexity of adding at the starting of the list, okay, that means prepend is order of 1. Clear? Okay, next let's try to remove this first node. Whatever we are creating is, whatever we have created, right? Let's try to remove that. Now what we have to do, this head pointer, whichever we have written just now, right, we have assigned to new node, right? It should point to the next node. Means this is the first node now. 50 has become the first node now from the previous operation. Now we have to point that head to the this node, which is the 10. Okay, and also this pointer needs to be removed. Earlier 50 we pointed to 10, right? Now this pointer need to be removed and head to be moved, because here also there is no iteration, right? Then because of that reason, because we are just moving the head and then we are removing this one, so for this also the time complexity will be order of 1. Okay, now let's try to add something in the middle. Now let's say we wanted to add between 20 and 30. We wanted to add this 50 node between 20 and 30 here. Here, okay. Like this, I'm just writing. Now this will be removed. So for this, what we have to do, to add something in the middle, what we have to do is, already there is a pointer present from 20 to 30. So that pointer, whatever is present here, needs to move from here. This pointer should be moved to this one pointing to here, and in the new nodes next pointer will be pointing to the next to next. I mean from previous to next. This connection will be removed, right? From here it will be removed, and from here we have to add the previous connection to here, and then this should point the next to the next node. That's when it will become like a linked list, correct? So here we have to find out the middle of the list, or wherever we wanted to add the value, right? So here we will say after 20 or after before 30, like that we will mention, right, where to just insert this node. So for this it has to go through from head, whether this is the 20 node, this is the 20 node, like that it has to search and go through each and every element in the list, and where we have to add this, right? Because of that iterations, for this particular operation the time complexity will be order of n, because every element it should check whether we, like the requirement is to add 50 after 20, so whether we have the element of 20 or not. Even if we take index also, we have to go through from head, saying that whether is it in the first index or is it in the second index, like that we have to go through each and every index to find out exact position where we have to insert this particular element. So in both the cases, when we want to insert an element into the linked list, the time complexity is order of n. Okay, and let's say we will try to remove this. We just added, right, this new 50 node. Let's try to remove. Even in that case, if you see, let's say we are saying remove this node which is of 50. So for that we have to again go through from head, right, whether the element is 50, element is 50, like that we have to search and compare the value in the each element to find out until we get this value of 50, right? That's when we can remove this. So here also we have to iterate through this entire list until we reach to the given element, right? So for this reason, the time complexity of this removing in the middle of the operation also order of n. Okay. Now let's say we are searching for an element. We are searching for 30. Okay. Now when we are searching for the 30, then from the head we have to iterate. Is it 30? It will compare the element value. Is it 10 equal to 30? No. Then it will go to the next node. Is 20 equal to 30? No. Then it will go to the next node, which is 50. Is 50 equal to 30? No. Then it comes here, which is 30 equal to 30. Here it will satisfy and it will return the result. Yeah, we found the value in the linked list and it will return the value. But for coming to here, it has done multiple iterational checks. So here I have taken 4-5 elements, so it's very easy. Let's say there is a linked list of some thousands or 1 crore nodes, then it will take lot of time, right? So the time complexity of this particular searching operation will be order of n. Okay, but whereas in the list, right, we have these indexes and it allows random access. I was telling when we talked about the differences, right? What is that random access means? Here when I say index 2 in the linked list, it will search this index whether 0 equal to 2, 1 equal to 2, then 2 equal to 2, like that every index it will compare and it will come here in the linked list because it does not support the random access. But whereas Python list supports the random access. So when we say 2, directly it will go to the second element because anyway that is contiguous memory allocation is present for the Python list, right? So directly it goes to that second index and it will give you the search option. That's why when searching for a particular element in linked list, the time complexity is order of n. But whereas when you are searching for a particular element in a list is order of the time complexity of that particular operation is order of 1 because it directly identifies, it has the random access. So it directly goes to that particular index and it will return you the value. That's why the time complexity of that operation is order of 1. Okay, hope this is clear. Now let's see the difference between linked list and list on a high level with respect to the time complexity. When we try to append, okay, when we try to append means at the end of the list, when we try to append, we have seen the linked list, it is a single operation because at the end we just have to adjust the tail and the next pointer to the none of the newly added list, right? So that's why the time complexity of that particular operation is order of 1. And next one is pop is to remove at the end. Remove at the end also, what we have done, we try to assign the try to get to the pointer where that is the last node, I mean last before node. So what we have done, we have traversed from head to every next element to identify that previous connection or previous pointer to reach to that particular location. So when we pop the time complexity of that particular one is order of n. This is for the linked list I am reading now. Next is prepend. Prepend means adding at the starting of the list. So what we have done for this, we just adjusted the head position and the node dot next we assign to the currently whatever is under the head, right, to that position. So that's why this is just a single operation because we are not traversing through the entire list, right? For that reason the time complexity of this operation is order of 1. Next is pop first. So similarly, when we wanted to remove from the first element, we just adjusted the head pointer and the next pointer, right? So that's why the time complexity of this popping means is removing removing the first element is the time complexity of that operation is order of 1. And here insert means when you wanted to insert in the middle of the list, middle means somewhere, like you have some list of 10 values, you wanted to insert after 8th value or wherever you want, right? So when you are inserting in between, the nodes in somewhere. It's not in the starting or it's not at the end of the list, right? So for that we have to traverse through every element in the list starting from head. So that's why the time complexity of this operation is order of n. Next is removing, and similarly for removing also we have to just see, right, like what is the value we have to search. We are removing some value 50, the element value is 50 or not, or wherever we wanted to remove, we have to get the previous, right, previous node of that. So we have to iterate through each and every element starting from head. That's why the time complexity of this remove operation is order of n. And let's say lookup. Lookup means when we are searching for some value, we have seen that even when we search with the value or even when we search with the index, the time complexity is order of n, because it has to traverse through each and every element in the list starting from head. These are the time complexity calculations for a linked list. Now coming to the list, right, because list is having the index, appending and the popping is very easy, because at the end we will do these operations. So pop also we don't have to traverse through everything. We know the last of the list n, index of n, right, the last index of the list, and then we can directly pop that up. Then prepend means finding the starting of the list in the memory is a bit difficult. That's why the time complexity of this particular prepend and pop first means the first element remove, adding and removing is we have to identify which one is the starting of the list, right? That's why the time complexities of these two are order of n. And similarly inserting in the middle of the list, even in Python list also we have to traverse through each and every element of the list, right? That's why the time complexity of these two operations are of n for the Python list. And then finally lookup by index, as I mentioned, right, lookup by index is very easy because it has the random access. So directly it goes to index and it will return. That's why it is a single operation. The time complexity is order of 1. But whereas if we wanted to go by value, search by value, we have to compare the each and every element to confirm this is the one we are searching, right? So to return that. So that's why we have it follows by the iteration. So the time complexity of this particular one is order of n. Okay, hope this is clear to you friends. In the next video we will see how to implement the linked list. Like here I am saying appending and just I mean pointing head to the next node or tail to the previous node, and all we have discussed today, right? So tomorrow we will see that in the code, Python code, how to assign those pointers and how can we achieve that. Hope this video is useful to you friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.